quickly hand you over to Okulo.
So, good evening, distinguished panel of judges. I'm Joe. This is John. This is Carolina. This is Ewan. And this is our app, Okulo. So, Okulo is a cross-platform accessibility app for colour-deficient users. We're going to run you through a quick demo of how the app works. So, on load, the user is met with a simple little guide of how each of the buttons works and how each button operates. And then we go to the camera. So here we see the camera in use, and from here you will see from the bottom the options will slide up, and the user can then input their color deficiency type. In this case, we are selecting Proton, and the two options above are monochromatic and high contrast. Monochromatic will shift everything but the problematic color to black and white, and high contrast will change the problematic colors to a more contrasted version. So basically, for the design and of the whole app, we really wanted to keep it really clean, really minimal, really sleek. So we just went with complete black and white, so that there would be no miscommunication of what everything was doing. We went with simple icons that were easy to understand, and the main design aspect was to keep it as clean as possible, so that there'd be no confusion on the user end. The app's initial prototype was created using JavaScript and the HTML element Canvas. So we've got a little example here. On this side, you see the original, and on this side is the canvas in action. So what's happening here is the webcam footage is being pulled onto the canvas, and then each pixel, its data is being then taken away, and the RGB values are being manipulated by an algorithm that was built from scratch that would detect the color, translate the color, and then perform a shift that would mean that problematic colors were then changed to something that would be more understandable. To talk more about going from browser to mobile, here's Ewan.
Thank you, Joe. Hello, everyone. Our initial plan was to use React Native and the Expo toolkit, with the phone performing all of the image processing and displaying it with Canvas. We had a look at Flutter, but we weren't really feeling brave enough to try image processing with a new language such as Dart, even with all the available tutorials and the help of Shaq's cake metaphors. We soon found out that we couldn't use Canvas or WebView with Expo, so we had to go with vanilla React Native. This meant setting up Android Studio to use the emulators and adding various lines of Java to get the packages working. So much for avoiding an unknown language. Just to get the RBA data from the image, we tested lots of NPM packages with React Native. These included React Native Image Crop Picker, React Native Get Pixels, React Native Image Pixels, React Native Image Crop Picker, React Native Pixel Color, React Native Color Matrix Image Filters, and the list actually went on, but yeah, we had several problems, as you can tell. We then eventually decided to pass all the processing to Google Firebase, where we could use Firebase functions in a Node.js environment, and store the pictures in Firebase storage and use the real-time database. This came with its own issues, including timeouts and unknown bugs, such as dirty rectangles and tainted canvases, sorry. I'll hand you over to John to explain what we eventually did.
Thank you. Hello. So as you can hear, doing this just became more and more convoluted and complicated as time went on. So I'm going to try and explain what's actually happening when the app takes a picture. So the user takes an image. That JPEG is uploaded to the Firebase storage. Using the Firebase cloud functions, we resize the image, make it a little bit smaller. The image is then converted into a really, really big array inside of a JSON file. It looks like this. And there's about 500,000 elements in that array. Like when you're doing cars, it's cool doing like loops and stuff, but looping over like 500,000 things is ace. JSON file, this JSON file, newly created JSON files, overwrites the initial image, and a download URL is input into a Firebase database. Meanwhile, back in the app is listening to these changes in the Firebase database. it hears a change. Oh, a new download URL has been generated. It downloads the file, extracts the really big array, and saves it locally. Once we have this array on the device, we run it through some like image processing stuff which we made ourselves. And once this is like gone up to the cloud, come back, we reach the next step. So this is like basically this line here is going to like draw the new image onto like a canvas inside of a preview of the app. Does all this, colors transformed. This has a bug in it which doesn't work, and so we can't do a live demo. Apologies. So that's kind of how it works. I'm going to pass you on to Carolina, who's going to talk more.
Thank you, John. So, I think the future ahead of us is really bright. Over the past 2 weeks, we've managed to achieve so much. We've made a successful Firebase integration. We've got a working React Native app, which we made for the first time. Well, almost working, except for the exception that John was introducing to you. And we managed to persevere as a team, even though we had problems. Nobody gave up. So, I think that we've done really well. And if by any chance we were given more time, we would proceed and do more. Like, if we got a week, we would make it more user-orientated. They could have profiles, they could have opacity, they could have sliders to adapt every filter to their own needs. We could do that, I believe. If by any chance we got a month, we would definitely try to implement the live view, which was our core idea, though unfortunately we didn't manage to get it on time. Then, if by any chance we were given a year, and we're lucky enough, we would use object recognition and other things which could help to introduce the world of color for people who can't actually see color, or even go to the world of people who are blind and explain what's in the image using voice and some generated data. That would be cool, wouldn't it? And if we were even more lucky, in 10 years' time, I believe we could just clearly inject that into people's brains. Thank you.
If anybody has any questions, please. If anybody has any questions, please. Yeah.